Hello everyone. Today's lesson is on Chapter 6, Section 4, Exponential Functions. Let's get started. Exponential functions. Our objective today is to be able to identify, evaluate, and graph exponential functions. Essential question would be, what are the characteristics of an exponential function? So a function of the form y is equal to a times b to the x, where a cannot be equal to 0, b cannot be equal to 1, and b is greater than 0, is an exponential function. The exponential function y is equal to a b to the x is a nonlinear function that changes by equal factors over equal intervals. Example 1. Does each table represent a linear or an exponential function? Letter A, x 0, 1, 2, 3, y 2, 4, 6, 8. So as x increases by 1, y increases by 2. So the rate of change is constant. So this is considered linear. So the rate of change is constant. As x increases by 1, y increases by 2. This is a linear relationship. Letter B. As x increases by 1, y is multiplied by 2. So as x increases by 1, y is multiplied by 2, so the function is exponential. Example 2. Evaluate each function for the given value of x. Y is equal to negative 2 times 5 raised to the x. X is 3. So that puts us at y is equal to negative 2, 5 raised to the third. This is equal to negative 2 times 125 equals negative 250. Example 2, letter B. Evaluate y is equal to 3 times 5/10 raised to the x. X is equal to negative 2. So take your negative 2 and substitute it in. Y is equal to 3 times 5/10 raised to the negative 2 power. That is equal to 3 times 4 which is equal to 12. Remember, this is 1/2 and it's raised to the negative 2 power. So this is the same as 1/2 raised to the negative 2 power. So both the numerator gets the negative 2 and the denominator gets the negative 2. So when you evaluate, that becomes 1 to the negative 2 over 2 to the negative 2, which basically they kind of switch positions in order to get a positive exponent. So 2 to the second over 1 to the second, which is 1. And that makes 0.5 to the negative 2, 4. Okay, on your own, examples 1 and 2. Does the table represent a linear or a nonlinear or an exponential function? Explain. So number 1 is x goes up from 0 to 1. Go from 8 to 4, or times 1/2 times 1/2 and times 1/2. So the table for number 1 on your own would be exponential. Number 2, as x is increasing by 4, it appears that y is decreasing by 1. We have ourselves a linear relationship there. It's constant. Number 1, exponential. Number 2, linear. On your own, number 3, y is equal to 2 times 9 raised to the x. If I was to take, I'm going to do this number 3 with x equals -2, x equals 0, and x equals 1/2. Okay. All right. So let's substitute in. So 2 times the 9 raised to the x, which in this case would be -2. So if you were to evaluate this out, this would be 2 over 81. Let's try if x is equal to 0. If x is equal to 0, you'd have y is equal to 2 times 9 raised to the 0, which is equal to 2. 9 raised to the 0 is 1. 1 times 2 is 2. And lastly, if x was 1/2, you'd have yourself y is equal to 2 times 9 raised to the 1/2 power, and that's equal to 2. This is the square root of 9, which is 3, to the 1/2 power. X at 1/2 would equal 6. We have a few decimals on number 4, so let's try that one using a calculator here. 1.5 times 2 to the -2 power. It's the same as 1.5 times 1/4, which is 0.375. If your x is 0, again, you're going to have 2 to the 0, or 2 to the 0 is 1. So when you have that case, again, you have y is equal to 1.5. When x is 0. And lastly, on your own, number 4, if you had y is equal to 1, if y is equal to 1.5 times 2 raised to the x of 1/2, that would be 1.5 times the square root of 2. And that would be on your own number 4. Let's move on to example 3, graphing. We're going to graph y is equal to 2 raised to the x, describe the domain and range. Okay, so basically we're going to do a little bit of a table here quickly. So I'm just going to put a little table of x, oops, and y. Sorry about that. So some of our favorite values would be starting at -2, -1, 0. I could keep going, 1, 2, and 3. So I'll do some mental math here. If x is -2, I would have 1/4 for y. -2, 2 raised to -2 would be 1/2 to the second, which is 1/4. If x was -1, we'd have 1/2. If x is 0, we'd have 1. If x is 1, you'd have 2. If x is 2, you'd have 4. And if x was 3, you would have 8. So the graph is going to look like this. Okay, so I've got my little graph going here, nothing fancy. So I'm going to plot a few points in. At -2, I'm down here at 1/4. At -1, I'm up here at 1/2. At 0, I'm at 1. At 1, I'm at 2. Excuse me, right there. At 2, I'm at 4. At 3, I'm way up at 8. So here's the function. It comes down. It looks like that. Exponential function. 2 raised to the x. 2 raised to the x. So the graph, you can see the domain is all real numbers. The range is all positive real numbers. It's not going to ever cross this x-axis. It's never going to cross it, because as you go further out in the negative range, it's going to get smaller and smaller, but it's never ever going to touch it. And it's going to keep getting bigger and bigger. Example 4, graphing a vertical translation. Let's try that one out. Graph y is equal to 2 to the x plus 3. Describe the domain and range. Okay, step 1. We're going to put our table together again. X and y. Okay, so we're going to use the same values, -2, -1, 0, 1, 2, 3. 1, 2, and 3. So what I'm going to do is fill in for the y. The y in this case, if I have -2, if I put 2 to the -2 and then add 3, I'd have 13/4. 13/4. -1, I'd have 7/2. 0, I would have 4. 1, I would have 5. 2, I would have 7. 3, I would have 11. So I have a table of values there of y is equal to 2x plus 3. So I was doing a lot of mental math there. Y is equal to 2x plus 3. So if I was to, it's basically example 3, but I'm going to plot these same 2 points. So what I'm going to plan on doing here is see if I can, here, let's do this. Okay, this is the table. I'm just going to pull it off there. I'm going to bring it over here. Okay. So I just put it right underneath the other one. Okay, so you can kind of see this is y is equal to 2x. And the table that I have right below it here is y is equal to 2x plus 3. So you can see the values are, the y values are going to be 3 units higher. Okay, so if I can just graph this one in blue. So at 0, I'm at 4. 1, 2, 1, 2, 3, 4. At -1, I was at 7/2, which is about 3.5. -2, I'm at 13/4, which is 3 and 3.25. Okay, it's right about in here. 0, I'm at 4. I already got that. 1, I am at 5. 2, I'm at 7. 3, I am quite a ways up there at 11. So I'm up off the screen here. So basically what this is the graph. It is y is equal to 2 to the x plus 3. It's a vertical translation. So from the graph, you can see the domain is going to be all the real numbers again, and the range is numbers greater than 3. Okay, the range never gets below 3 here. And it's considered a 3-unit translation of this graph, y is equal to 2x. And that's example 4. So graphing the function on your own, y is equal to 3 to the x, y is the 1/2 to the x, and 7 is equal to -2 to the 1/4 to the x. We will do y is equal to 3 to the x. When x is 0, so x and y. Kind of watching my time here in my video. I don't want to go too far. So this is 0. If x is 0, this is 1. Okay, anything to the 0 property is 1. So at 0, we're at 1. 2, it 3 squared is 9. So it goes up, kind of goes like this. Y is equal to 3 to the x. Kind of similar to the 2 to the x. And that's pretty much. I don't want to go too long today here, so I'm going to cut this into a couple of videos. We'll do the second part tomorrow. What I'm going to do is I'm going to post the assignment today. You can look at the second video tomorrow, but I'd like to have it due by Thursday. It's a short practice. Hopefully this is helpful for you to get started on exponential functions, and we'll talk to you soon. Miss you guys all, and we'll talk to you later. Take care. Bye-bye.